In ovens, the plastic molding is fully cured so it can withstand the plating process. In the plating process, the strips are loaded onto carriers and dipped in a series of chemical and water wash baths. In the plating baths, with anodes of tin and lead, the leads are plated with a layer of solder so that the chips can be easily attached to a printed circuit board. In this process, the individual devices are removed from the strips. The leads are cut from the frame on 4 sides and bent into their final configuration. The formed leads are then cut to their final length. The chips are punched out of their frames, and each one is now an individual package. The individual chips now undergo testing. They are loaded onto burn-in boards which will be placed in ovens. These boards consist of many electrical sockets. When connected, they allow electrical contact with each chip. In these boards, the chips will be stressed far beyond normal conditions. Weak chips are forced to fail prematurely before they are put into a customer's product. The loaded boards are slid into their electrical receptacles. In rows and rows of burn-in ovens, the chips are powered up and exposed to high temperatures for several hours. This stress encourages potential defects to occur faster. In another test, the chips are exposed to contrasting cold and hot temperatures before they are electrically tested. This large computer controls 2 testing handlers. Inside the handler, we see the chips move to the testing region. An electrical socket tests each lead to determine performance characteristics. Depending on the test results, the chips are sorted as those that meet specified requirements, those that meet lower requirements, and those that have failed. The chips that pass are marked with a logo. They are laser marked, visually inspected, and packaged for distribution. Soon, these chips will be placed on a printed circuit board. The maze of transmission lines are the conductive paths that signals use to travel between chips and to the outside world. In this cross-section of a circuit board, we see these transmission lines are routed through several different layers using channels called vias. The materials surrounding the transmission lines and the line's dimensions contribute to capacitance, resistance, and inductance, which affect the signal's performance. As with chip design, computer-aided design programs facilitate line geometry and routing, as well as the layout testing of printed circuit boards. These designs go on to be fabricated into the actual boards, which will hold various electronic parts. The bare printed circuit boards are loaded onto the assembly line.